Good morning, everyone. Today we are going to explain about the results from our practice. We are going to realize a video explaining the results obtained on the laboratory practice, where the temperatures were measured and the transference area were also measured for the heat exchanges.
Reagents and materials. One graduate cylinder, one cooling coil, one large plastic container 10 liters, two perforated rubber stopper, 100 degrees Celsius thermometer, two universal supports, one fish tank pumps to recirculate water, hose to connect the coil, one beaker of 1 liter, one beaker of 200 milliliters, one warming rack, and 3-finger forceps. The universal supports were placed to place the recovery coil, the hoses were placed on it, and the pump was placed on the residence with water.
The lab practice was divided into different steps that consist. The first one in basically the calculation of outlet temperature in a heat exchanger. This first part consists in first heat 1 liter of water on the electric grill to 60 degrees. While the water is heating up, install the heat exchanger system as it is shown in the lab report. Then we all need to install the system and measure the flow of water in the inner tube. For this, we measure with the graduated probe to the volume of water that comes out of the inner tube to like for 10 seconds, and later we calculate the flow in milliliters per second. We carry out the same measurement for the flow in the shell. And once we had the flow measurements, we both in the inner tubes and in the shell, the hot water was placed in its place together with the pump, and the system is put on in operation.
Now, let's go with the representation of her data to a problem. Here we have that a liquid stream is a cooler from 65 Celsius degree to 30 Celsius degree with a countercurrent heat exchanger. Fluid flowing countercurrently with this stream is heated from 38 Celsius degree to 55 Celsius degree. Now we are going to calculate the log mean temperature difference. Here we can see a graphical representation of our data represented in a countercurrent heat exchanger. Now, on one end of the equipment, in the first temperature difference, we have a 30 Celsius degree minus 28 Celsius degree that is equal to a 2 Celsius degree. And the other end, in the second temperature difference, we have a 65 Celsius degree minus 55 Celsius degree that is equal to 50 Celsius degree. Now we are going to calculate the long mean temperature, that is, which is 5 minus 2 Celsius degree, between natural logarithm of 5 by 2, and that is equal 3.274 Celsius degree. And we are going to conclude that the long mean temperature difference is 3.274 Celsius. And that's all.